Number 13. Find the inverse of f of x equals 3 over x plus 5. Now remember, when you see inverse, we need to think about switching x and y. And so in this case, f of x represents y. So what we're going to do is we're going to switch it, and we're going to try to solve the equation x equals 3 over y plus 5 for y. So if I want to solve this, I'd first notice y plus 5 is dividing from 3. If I got to get the y isolated, I've got to get it out of the denominator. So the first thing I'm going to do is multiply by y plus 5. So if you multiply, you got to do that on both sides. Whoops. So I'm going to take y plus 5 over here, multiply it times x. Now this goes away, and I'm going to have to distribute over here. So I have xy plus 5x. So I distributed this. I went multiplied and multiplied. And I'm setting that equal to 3. Now I'm going to get the y by itself again. So I'm going to subtract 5x here. And so I'll subtract 5x from over here. And that goes away. So now I have xy equals 3 minus 5x. Last step, to get y by itself, you divide by x. Now when you divide, you got to divide the whole side like this. Now if we want to reduce, what we can do is we would now say this is f negative 1. That would be the terminology. Equals, what we could do if you wanted to divide it, simplify. You can't simplify right now because that's in the form of a term up here. You have to change it to factors. And so I can't really do that way, but what I can do is write it as two fractions. I can say this is 3 over x minus 5x over x. And of course, if you have 5x over x, then you could cancel away the x's and say that's just minus 5. And so I'll say this is 3 over x minus 5. Now that should be my inverse function. Now let's check this out. How can I check it out? Well, I go to my graph, and I'm going to graph the first equation, which was 3 over x plus 5. 3 over x plus 5. And we're saying the inverse is 3 over x minus 5 on the outside. We're saying this is the inverse. Now, how do we know if it's the inverse? We need to see if it reflects on the line y equals x. That's what we want to know. Will it reflect on the line y equals x? Sorry, let me get this out. Okay. I want to know, will this reflect on the line y equals x? So I'll graph that real quick. And so as you look, you can say, man, I can't really tell if it's reflecting perfectly or not. So that's where this calculator trick comes in handy. If you remember that if I want the calculator to tell me what the inverse is, what I do is I press Menu, Actions, Text. And I'm going to say, because we're changing x and y, I'm going to say, if you remember, it's x equals fly. And I kind of said, let's stay fly, my friends. If you remember that saying, x equals fly. What I mean by that is I'm taking my function f1, it looks like fl. So x equals fl, or f1 rather. And instead of putting an x there, I put a y, because what am I doing is I'm changing my x and y. This is y equals f1 of x. We're saying that's the same thing as y. So y equals f1 of x. What I've done is I changed it to x equals f1 of y. As soon as I take this to the x-axis, it'll graph my answer. And notice how it goes exactly on top of the red, which we had here. So we did do it correctly. That is the right answer.